The Fuelblock 50 is a liquid-fueled processing and delivery system capable of supplying two 25 megawatt aero-derivative gas turbine generators. The Fuelblock 50 can also be configured to supply a single 50 megawatt turbine generator. The module and all equipment are assembled at Lonsdale and fully commissioned before shipping to site. Once at site, the Fuelblock 50 is connected to prefabricated 85 kilolitre fuel tanks to provide a fast, complete solution for liquid fuel storage, processing and delivery. There are 12 fuel blocks currently in service in Indonesia. Air conditioner with cooling capacity of 10 kilowatts is optionally available with the Fuelblock 50. Likewise, a fire detection and indication panel can be supplied to integrate into the site fire alarm system. The MCC is a modular withdrawable design providing Form 3B protection. It houses all motor variable speed drives and the programmable automation controller. The MCC has been designed to easily facilitate fault finding and maintenance tasks. The pack monitors and controls all instrumentation and electrical equipment associated with the fuel block. A local HMI permits manual or automatic operation and short-term data trending. Third-party remote access and control is available via Modbus gateway or Ethernet connection. The auxiliary skid is located along the same wall of the fuel block as the air conditioner, fire panel and MCC. It is modular in design and is scalable to suit the specific requirements of each site. All pipe headers, external piping connections and cable entries are located along the opposite wall to the MCC and auxiliary skid. Fuel tank connections are on the left, turbine connections on the right, with tanker unloading connections at the far left side. Pressure piping for the fuel block and all modules is fabricated from 304L or 316L stainless steel materials, complying with ASME B31.1. To provide resistance to potential aromatic hydrocarbons, elastomers used for fuel oil service are Viton or PTFE. The fuel block is able to receive raw fuel from tankers and/or dedicated bulk fuel tanks. The raw fuel is transferred to a dedicated raw fuel tank. Pumps are optionally available to facilitate tanker unloading or bulk fuel tank transfers. Vane-type positive displacement pumps are employed for all fuel block transfer operations. The pumps are direct coupled to variable speed controlled 3 kilowatt electric motors. An internal relief valve protects the pump and downstream piping. The raw tank suction header is connected to the raw fuel tank via a floating suction arrangement. The raw fuel pumps draw fuel from the tank to their dedicated centrifuge for treatment. The centrifuges are rotating disc-type separators. They process continuously to produce clean fuel and heavy phase discharges. Variable speed controlled 18.5 kilowatt motors drive the bowls via a centrifugal clutch. Bowl operations and discharges are performed using process water. Treated fuel from the centrifuge is transferred to the clean fuel storage tanks via the clean tank inlet header. Impurities such as sodium or potassium may be present in raw fuel, which cause corrosion in a turbine's combustion section. Fuel washing is a process where demineralised water is introduced to the centrifuge feed to dissolve and extract the metal alkali impurities from the fuel. The clean tank suction header is connected to either one or two clean fuel tanks. The tanks have a floating suction arrangement. The fuel feed pumps draw from the clean tanks, with each pump typically servicing a dedicated turbine. If a fuel feed pump should fail during normal operation, the other pump will start if not already running, and the crossover valve will open to maintain fuel supply to both turbines. Accumulators are provided with the last chance filters to reduce fluctuations in pressure at the turbines. Clean fuel return lines in the fuel block are fitted with pressure control valves and flow metering to ensure constant delivery pressure and flow availability at the turbine connection. A bypass line and valve has been incorporated in the fuel block to facilitate closed-loop fuel treatment and line flushing. When the valve is open, fuel will circulate from the raw fuel tank through the centrifuges to the clean fuel tanks, to the last chance filters and back to the raw fuel tank. Flushing is typically performed after construction completion or as part of operator training. The auxiliary and waste systems are modular in design and can be scaled to suit the specific requirements of each site. An oversized instrument air header provides additional storage capacity in the event of a disrupted supply. A self-contained screw-type compressor with integral refrigerant dryer can be provided for maintenance activities or at sites without a dedicated instrument air system. Process water is used for centrifuge bowl operations and fuel washing. A cartridge depth filter is provided to remove particulate matter from the process water. A 2,000 litre storage tank, pressure pump and accumulator can be provided for sites without a process water system or with intermittent supply pressures. Centrifuge heavy phase waste, bowl discharge fluids and fluids recovered from the last chance filters are received in the common sump of the fuel block. A sump pump can be supplied to transfer fluids from the sump to dedicated waste storage tanks at site. The sump high level switch operates the diaphragm-style pump automatically. Alternatively, waste fluids and particulate can be processed in the fuel block. The waste is pumped through an ultra-fine bag filter membrane to the 2,000 litre settling tank, where the particulate-free fluid gravity separates into water and diesel. The water phase is further treated in an oil-water separator before being discharged to the site stormwater system. The diesel phase is reprocessed by the centrifuges. A pre-filter module is available for initial filtration of raw fuel received from tankers or bulk suppliers. The filter employs surface-style elements that automatically back flush when required. Incoming raw fuel can be paused during a back flush or allowed to continue unfiltered to the raw fuel tank. Fuel particle analyzers can be supplied to provide ISO 4406 code sample data and long-term trending of fuel particulate levels of the incoming raw fuel supply. Fuel treated by the centrifuges. Clean fuel returned from the last chance filters. The fuel tanks are a self-bunded double-wall design with a safe fill capacity of 80,280 litres. All internal plates and members are 304L stainless steel. Pre-assembled modules complete with piping and actuated valves are installed in the fuel tank valve bay. Level instrumentation is fitted to the tank and easily connected to pre-wired sockets at the module's terminal box. A floating suction line ensures the pump suction is suspended in the upper fuel inventory. An internal drain line is included with each tank. The drain line draws from the bottom of the tank where any water or particulate matter will settle. Clean fuel tanks may be configured to automatically polish the clean inventory by processing with the centrifuges. Raw tanks are typically de-watered as a scheduled maintenance activity. The last chance filters are located at the turbines to provide final filtration of clean fuel. The filters are a duplex configuration with individual manual isolation valves. Upstream and downstream pressure instrumentation alerts the operators when a filter is blocked. An accumulator is fitted at the discharge to provide stored fuel for emergency disruption events, such as operation of the crossover valve. A diaphragm-type pump transfers fuel captured as a result of filter element changes or a turbine fuel rejection event. This waste fuel can be transferred to the fuel block for collection or treatment and recovery. RJE has extensive experience with site piping and cable design and construction. Standard piping and racking packages can be supplied for 1, 2, 3 or 4 generator sites. These can be designed around a customer layout or supplied as per the typical reference plant layout. As with all other piping in the Fuelblock system, these pipes are all stainless steel and supplied in bolt-together spool arrangements. Racking systems are all galvanised steel constructed and configurable for many plant piping and cabling arrangements. The system is fast to install and requires minimal flushing, as all spools are cleaned, flushed and capped prior to dispatch. Remote access to the automation system enables RJE automation engineers to monitor operation, as well as make minor software changes. Also, should a catastrophic event occur that requires the replacement of the PLC or HMI, the correct version of software can be installed remotely. Quick, low-risk unloading from truck to foundations. 4 hydraulic cylinders with 1500mm stroke. Battery-powered system supplied with controller and hoses. Under development is the Fuelblock 100, which serves either 4 25MW or 2 50MW turbines. Using the same centrifuges and fuel pumps and 150 kilolitre fuel tanks that can be supplied as either dedicated raw or clean tanks or a single combination raw or clean tank.